Okay, in this lesson, we're going to have a look at parabolas, okay? So everything to do with sketching and how to sketch, how to find x-intercept, y-intercept, all of that, okay? So I'm pretty sure you guys would have done parabolas over the last couple of years in year 9 and year 10. But what I'm going to do, I'm going to assume you have no knowledge and I'm going to teach you everything you need to know from scratch, right? So you'll know everything you need to do, know for methods 1, 2. So let's get started. Let's get started with y is equal to x squared, which is the basic equation of a parabola. And it looks like this, as probably already know. It's a basic parabola. We're going to look at what everything we can do to this graph, so in terms of moving it around, squishing it, reflecting it, all the different things. But before we do that, though, we need to look at some properties of parabolas, okay? There's a few properties you need to know. Property number 1 is this thing called the turning point. Turning point. Okay, you can kind of guess, it's pretty obvious from the name. It's the point where the parabola is kind of, it's at either the minimum, or if there's, for example, this parabola, it's called, this will have a maximum turning point, okay? So first feature is going to be turning point. It's kind of the point where the graph turns around. Second feature is going to be x-intercepts, right? We know what x-intercepts are. It's where the graph crosses the x-axis. So these two are going to be your x-intercepts. Third thing is going to be your y-intercept. So obviously it's where it crosses the y-axis. So this would be y-intercept for sure. And the last thing you need to know is this thing called axis of symmetry. Axis of symmetry. Symmetry, I don't know how to spell symmetry. Pretty sure that's it. But if that's wrong, don't blame me. Not an English tutor. So this is turning point. Pretty much what is axis of symmetry? Axis of symmetry is the line that if you draw straight through the x-coordinate of the turning point, right? It's the graph on the right is symmetrical to the graph on the left of that line, right? It's the axis of symmetry. It's symmetrical about that straight line. So this has the equation x is equal to whatever the x-coordinate of the turning point is. Okay, so again, we'll look into more detail what that is when we start sketching. All right, let's first start by looking at dilations of the parabola. Okay, so pretty much y, so this would be y is equal to a times x squared. So a is the dilation factor in this case. So I'm going to draw the basic x squared graph. Is the exact same one I drew before. So it looks kind of, okay, let me try to get this right. Boom. And boom, still kind of ugly the shape, but will do. So now we're going to look at what happens, how does the graph of y is equal to 2x squared look like? Okay, so pretty much if the number in front of just x squared is just 1, what happens if the number increases to 2? So if the number is higher, then the graph is going to be squished in more, like so. Like that, and like that. Okay, so pretty much the higher the number, the more squished in the graph is. Now, what would the graph of half x squared look like? Well, half is less than 1, right? So if the number is smaller, well, it's going to be wider, like so. Boom, and boom. So you can see the difference. The higher the number, the more squished in the graph. Simple as that. So next thing we need to look at is a reflection, all right? So let's think about what a y equals negative x squared looks like, okay? Basically, it's a simple x squared graph, what we learned just then. It's a basic parabola, except it's flipped upside down. That's what a negative x squared graph looks like so. So can you guys tell me, what about the negative 2x squared graph? Okay, is that going to be narrow or wider, right? In this case, it's going to be narrow, like so, right? So pretty much you don't need to worry about that negative sign. You just need to look at the number. If it's a bigger number than the one which was in front of x squared, then it's going to be more squished in. It's going to be skinnier, right? So what about negative half x squared? As you probably might have guessed, it's going to be a bit wider, like so. Okay, so pretty much, okay, so we covered dilations, which is I like to think about as squishing the graph in and out. Reflections, which I think about as flipping the graph upside down. Okay, again, you'll know more, these are called transformations. When we start doing the lesson on transformations, you guys will understand more why this stuff is happening. But let's keep going. The last sort of transformation is this thing called translations, okay? So translations are basically moving the graph around. So dilations was squishing, reflections was flipping. This I like to think of it as moving. Okay, so again, y equals x squared, same graph, same exact thing we learned so far. What does x squared minus 3 look like? Well, what I did was I moved it down, moved this graph down by 3 units. Okay, so pretty much the exact same graph, except I moved it, oops, can't do that. So the exact same graph, I moved it down by 3 units. So it's going to look the exact same shape, but it's going to be moved down by 3 units, okay? So if the turning point of this one is pretty obvious, it says 0, 0. The turning point of this one would be 0 and negative 3, like so, okay? What about x squared plus 5? As you can probably guess, x squared plus 5 is just up by 5 units. Okay, it's the opposite of moving down because it's plus instead of minus. So the graph, exact same shape, but it's going to be moved up by 5 units, like so. So you can see if the number is on the outside like so, then the graph is being moved up and down. Okay, what about these graphs here? Okay, so now I put the plus and minus the number inside the brackets. Okay, what do you think? Which way do you think I move the graph, the purple graph? So y is equal to x minus 3 squared. Again, I'm going to draw the basic x squared graph. Okay, where do you think y is equal to x minus 3x is? Minus 3 squared is. Okay, what this is, actually I moved this graph to the right by 3 units. Okay, now you might be saying, okay, hang on, this is a negative, right? It's a negative. Why am I moving it right? Shouldn't it be left? Well, no. When it's inside the brackets, right, it's opposite. So if it's a negative 3, well, I'm actually doing the opposite and I'm moving it to the right by 3. Okay, so this graph will look kind of like this, like so. Okay, so if the turning point of the original x squared is 0, 0, the turning point of this graph would be 3 and 0, like so. Okay, so can you guys guess what x plus 4 is? Well, it's plus, but remember it's opposite when it's inside the brackets. So it's going to be left 4 units. Okay, so the graph will look kind of like so. So again, exact same shape as the other ones. I'm just moving it left and right. So turning point would be negative 4 and 0. Okay, so these are all the different ways we can kind of change the basic x squared parabola. Okay, so all of these parabolas, you'll notice they have this equation. Y is equal to a x minus h squared plus k. This is called the turning point form. TP, turning point form. Okay, in this lesson, there's other forms of parabolas, but in this lesson, we're going to learn how to sketch these. Okay, so pretty much, right, the first thing we can get from these sorts of graphs is the turning point, and we'll go more into detail as we do more questions. So question number 1 is sketch the graph of x squared minus 9. Okay, what do you think? Which way has this graph been moved? Well, the number's on the outside, not inside the brackets. So it's going to be moved either up or down. And because it's negative 9, it's going to be moved down 9 units. So the basic x squared graph moved down 9 units. So the turning point is 0, negative 9. And it'll look like so. Again, try and make it as symmetrical as you can. Right, it has to be nice and smooth. Alright, so that's basically the graph. Now, I'm not asking, now you can find x-intercepts if you wanted, but I'm not asking you to find it just yet. Okay, we're going to do that soon. So what about this graph, okay? Well, first, always identify the turning point, okay? So which way has this graph been moved? Well, this negative 2, if you remember, is just a dilation, right? Because it's multiplying the x squared. So if you go all the way back here, see negative 2x squared was just a dilation. It just flipped the graph, and then it's this purple graph over here, right? It's that graph. So it's not moving the graph back. Right, so what we need to worry about in this question is the negative 4. Which way is that moving the graph? Then the graph is moving down by 4 units, right? So the graph of the turning point, the x squared is just 0, 0. Normally, this is just x squared. It's being moved down by 4 units. So down 4 units like so. Okay, so that's step number 1. So it's like I said, I mentioned I was going to tell you the steps. Step number 1 is to find the turning point. Okay, like we did. And we did in this question as well. We found the turning point first, 0 and 9. Right? So step 1, find the turning point. Okay, so let's do it. For this graph, we find the turning point is going to be, because it's being moved down 4 units, we can say 0 and negative 4, like so. Like so. Okay. So now, once you find turning point, step number 2 is going to be to find x-intercepts. Right? X-intercepts, I'm going to show you how to do in a second. X-intercepts. Then third step is to find the y-intercept. Then after all that, you should have enough information to sketch the graph. Okay, let's do it. So I'm not asking you to find the x or y-intercepts for this graph. Not just yet. We're going to do it in a second, but I'll just tell you the steps. So we have x minus 4 squared, but it doesn't look like, if you think this is the correct answer, guys, I'm not happy with that, right? Because once we find the turning point, you need to think about the shape, the negative 2, right? What is negative 2 doing? Well, if you recall, if you go all the way back to reflections, the negative 2 is actually flipping the graph and making it skinnier, right? So we find the turning point for this graph, which is 0, negative 4. But because of that negative 2, it's going to flip the graph. So it's going to be upside down, right? And it's going to make it skinnier, like we talked about before. So actually, this would be your final graph. So step number 1, find the turning point. Then step number 2 and 3, which was x-intercepts, y-intercepts, but in this case, you'll notice there are no x-intercepts. So step number 4, which was sketch. So to sketch, you need to know what sort of dilation there is. So that's the whole process. If that didn't fully make sense, don't worry, we'll do more questions. So we'll do this one first. So first step number 1 was find the turning point, okay? So obviously this is moving the graph up 2 units, right? What is the plus 5 doing? Because it's inside the brackets, it's moving the graph left, right? It's opposite, so left by 5 units. Okay, can you guys tell me what are the coordinates of the turning point? Well, this is my parabola, right? It's being moved up 2 units, so 1, 2, and then it's being moved left 5 units, so 1, 2, 3, 4, 5. It's going to be roughly here. Oh, not there, here. Okay, so it's being moved up 2 units, so the y coordinate is 2. It's being moved left by 5 units, so x coordinate is negative 5, like so. Again, we don't know the shape yet, so I'm just finding the turning point. I just drew the shape just to show you. Okay, now we need to think, is there any dilation factor? Well, the dilation factor over here, you can just think is 1, right? So it's not being squished in, it's not being expanded, it's not being flipped because there's no negative, right? So then it's just a basic parabola shape, like so. Okay, or maybe I'm going to draw a bit to the right to make it easier for ourselves. It's going to be something like that. Okay, let me try again, here and here. Okay, the reason I did that is to make sure every parabola always crosses the y-axis. So you can't, if you drew this parabola like this, where it doesn't even touch the y-axis, you'd be wrong, right? Because every parabola will definitely have a y-intercept. So you make sure every parabola that you draw goes to the y-axis. Okay, let's keep going. What about this graph? Well, turning point. Well, we know it's being moved up 18 units, so the coordinates of the turning point will be the y coordinate will be 18. What's the x coordinate? It was negative 1 inside the bracket, so x coordinate will be 1. So it's being moved 1 unit to the right and 18 units up. Right, so that's your turning point. Step number 1 done. Okay, now in this question, what I'll actually make you do is I'll quickly make you find the x-intercepts. Let's do it. What's the rule for x-intercepts? It's always the same no matter what graph you're drawing. So you make y equal to 0. Now y is 0 is over here. So 0 is equal to negative 2 x minus 1 whole thing squared plus 18. Now we did this question last lesson, literally last lesson, solving by comparing the square, right? So you take the whole number to the other side, divide by 2 and so on and so forth and solve for x. Okay, so actually I want you guys to try apply what you learned last lesson and find me the x-intercept. Can you do it, please? Okay, so if you did the working out correctly, you should have these two. So x is equal to 4 and x is equal to negative 3 as your solutions. So pretty much what are the coordinates of your x-intercept? Well, the x coordinate you got were 4. What's the y coordinate? Well, you made the y coordinate 0. So your y coordinate is 0. So you have 4, 0 and negative 3, 0 as your x-intercepts. So again, your coordinate, your turning point is 1 and 18 over here. Your first x-intercept is negative 3, so it's going to be over here. Your second x-intercept is going to be 4, so it's going to be roughly over here. And you can kind of see the shape forming roughly, right? So again, so step number 1, find x-intercept. Step number 2 is to find the y-intercepts. Okay, so to find the y-intercept, what's the rule? It's always the same. You make x 0, right? So you take this x up here and you make it equal to 0. So you have y is equal to negative 2. 0 minus 1 squared plus 18. So you have y is equal to negative 2 times 1, because negative 1 squared is just 1, plus 18. And y is equal to pretty much negative 2 times 1 is just negative 2. So negative 2 plus 18 is 16. So y-intercept, what's the x-coordinate? X-coordinate is 0. Y-intercept, y-coordinate is 16. Like so. Okay, so you have 0, 16, which should be roughly over here. And you can kind of see the parabola shape forming. And also you'll notice because it's a negative 2, it's being flipped down because of the negative and squished in because of the 2. So you'll see kind of this is your parabola over here. Make sure it goes through all of the coordinates, like so. Okay, and make sure you label all the coordinates. Negative 3, 0, 4 and 0, and 0 and, what was it? 16. Yes, 16. Boom, like so. So I just showed you step by step how to do all of these questions. I'll just sketch any parabola in turning point form. So it's time for you to have a go. Once you pause the video and do it. So make sure you do x and y intercepts as well. Alright, I'll do it now. So first question was x minus 3 plus 1. So step number 1, find the turning point. Okay, let's find the turning point. To find the turning point, you need to find which way it moved. Well, it's being moved up 1 unit. So the y coordinate is 1. And it's being moved to the right 3 units, right? It's inside the brackets in negative 3. That means it's being moved to the right 3 units. So the coordinates of the turning point will be 3 and 1, like so. Next, you need to find, let's put it here. Next, you need to find the x-intercept. So step number 2 was find the x-intercept. To find x-intercept, make y equals 0. So 0 is equal to negative x minus 3 squared plus 1. So I'll actually solve this for you guys to show you how it's done. So you take 1 to the other side by making it negative 1. So subtracting 1, negative x minus 3. You can get rid of negative from both sides by multiplying both sides by negative 1. Multiply by negative 1. So you pretty much have 1 is equal to x minus 3. x minus 3 squared, sorry. X minus 3 squared. So now you need to square root both sides. Remember, we did this in completing the square lesson. So square root of 1, and every time you square root, what do you have to do? You have to do plus or minus is equal to x minus 3. Right? So then what's square root of 1? Well, square root of 1 is just 1. So you have plus or minus 3, x minus 3. And lastly, you take 3 to that side by adding. So you have 3. So plus 3 plus or minus 1 is x. So what are your two solutions? Your two solutions are x is equal to plus 3 plus 1, or x is equal to plus 3 minus 1, like so, which is pretty much 4 and 2. Right? So your two x coordinates are 4, 0 and 2, 0. So x-intercept, sorry. So we have 4, 0, which let's say is over here, because remember this is 3 and 1. 4 will be a bit to the right. And what was the next one? 2, 0. 2 will be over here, let's say. Okay, so that's the y-intercept done. Step number 3 is to find the y-intercept. So x-intercept is done. So step number 3 is to find the y-intercept. Y-intercept x is equal to 0. So y is equal to negative. Remember, is this x is replaced with 0. Negative 0 minus 3 squared plus 1. Y equals negative. Negative 3 squared, guys, is 9. So negative of 9 plus 1. So negative 9 plus 1 is nothing but negative 8. Like so, your y-intercept is negative 8. So it's all the way going to be roughly around here. 0, negative 8. So you can kind of see the shape of the parabola now, hopefully. So you can see it goes through all the coordinates, turning point there, and comes down like so. Boom, boom. Okay, so that's the first one done. I took my time with that one. I'm going to go through the next couple a bit faster. Okay, so turning point of this one is negative 3 and negative 2. So it'll be kind of over here. Okay, x-intercepts. Again, make the rule y is equal to 0. So you make y 0 is equal to negative 1 over 2, x plus 3 squared minus 2, like so. So start solving, take 2 to the other side. 2 is equal to negative half, x plus 3 whole thing squared. Okay. Then what do? You take negative half to that side. Or you can, another way you can think of this, guys, is the same as negative x plus 3 squared over 2, right? It's the same thing. You can think of it like that and then multiply by 2. Or we can do the normal way. So what we can do is say, okay, this is negative 1 on 2 is multiplying. So we're going to take it to the other side by dividing. So 2 divided by negative half is equal to x plus 3 whole thing squared. Okay, let's do it. So now to divide, you need to flip the sign. Flip it by saying 2 over negative 1. 2 over negative 1, like that. So pretty much you have negative 4. Right, so you flip it and multiply. So you have negative 4 is x plus 3 whole thing squared. Now you'll notice something weird here. If I take the square to the other side, right, what happens? Square to the other side, I'm trying to square plus or minus square root of negative 4. Now can you tell me, can we square root negative numbers? No, that's not a thing that can happen. Square root of negative numbers is undefined. No two numbers multiplied by itself, no number multiplied by itself is going to be a negative number. The square root of negative number cannot happen. Right, what does this mean? Does that mean there are no x-intercepts? Well, you're right. There are no x-intercepts. So every time you try and do this, guys, and you get negative inside of square root, pretty much there's not going to be any x-intercepts. So you don't have to worry about that. So the only thing we can do is find the y-intercept next. Y-intercept, you make this, remember parabolas always have a y-intercept no matter what. But like we just proved, the parabolas may not always have a x-intercept. So y-intercept, the rule is y is equal to 0. X is equal to 0. So y is equal to negative half multiplied by 0 plus 3 whole thing squared minus 2. So y is equal to negative half. 3 squared is just 9 minus 2. So y is equal to negative 9 on 2 minus 2. Again, fractions, adding fractions. Negative 9 on 2 minus 4 over 2. Y is equal to negative 13 over 2. Like so. So your y-intercept is 0, negative 13 over 2. Boom. That's it. So 0, negative, remember the coordinates of the turning point was negative 3 and negative 2. Because it's being moved left 3 units and down 2 units. Like so. So then your y-intercept, negative 13 on 2 is roughly negative 6. So negative 6, let's say somewhat over here. And like so you can see, because of the negative half over here, it's being flipped down. And because of the half, it's making it fatter. So you can see it's a very fat parabola. I don't think I should be calling parabolas fat, but it is. So who cares? 0, negative 13 on 2. Boom. That's it. Okay, so you sketch that one. Let's keep going. Once you have a go, did I give you any more questions? No, there was just 2 there. So this time, guys, what do you need to do is actually complete the square yourself. So these aren't in complete the square form. So complete the square and then sketch the graphs. Let's do it. So let's do it for this question. So we need to complete the square. So y is equal to complete square, I'll do it quickly. X, this sign comes down, minus 2. So b divided by 2. Minus 2 squared minus 5. Y is equal to pretty much, you should have gotten x minus 2 squared minus 9, like so. So pretty much we're sketching this graph. Then you need to find the x-intercepts. I'm not going to show you. Hopefully you understand by now. The x in 2 plus 3. Cut, by the way. Okay, so the x-intercepts you should have gotten are 5 and -1. Right? So let's do it. So first, let's sketch the turning point. Sorry, I jumped the gun. We need to first find the turning point first. What's the turning point? It's being moved down 9 units. So the y value is -9. The turning point is being moved which way? It's being moved to the right 2 units. So it's going to be turning point is 2. So 2 to the right, 9 down. So let's say it's roughly over here. 2, -9. And the x-intercepts are -1, which should be here, and 5, which should be, let's say, roughly over here. Okay? Boom. Next, we've done the x-intercept. Now we need to find the y-intercept. Again, same thing what we've always been doing. Make x 0. X equals 0. So y is equal to 0 minus 2 squared minus 9. So y is equal to 4 minus 9, which is -5. So -5 is roughly over here. Okay. So now sketch through all points. Like so. Boom. And boom. Like so. That's it. Okay, and make sure you label. Did I label all the coordinates in this graph? Yes, I did. I see I labeled turning point, I labeled y-intercept, and even in the previous graph I should have labeled. I've completely forgot, but I'm glad that I noticed, right? You should have labeled your x-intercepts. I forgot. So 4 and 0, and 2 and 0. So make sure you label everything that you have. It's really important. So let's label all our intercepts now. So x-intercept was 5, 0, and the other x-intercept was -1 and 0, like so. Okay, so that's the first graph. 2 more questions, quickly do it. I'll quickly complete the square. So you have y is equal to 2x squared minus 4x plus 5. I'll leave it on the outside. 2x minus 2 squared minus 4, pretty much. 2 squared is 4, close brackets, plus 5. I'm skipping a lot of steps. 2x minus 2 squared minus 8 plus 5. Y is equal to 2x minus 2 squared minus 3, like so. So now we completed the square. So this is a complete square. Pretty much, this is the graph that we're sketching. Okay. So again, first find turning point. Turning point is going to be, well, it's being moved down 3 units. So -3, and it's being moved which way? Right 2 units, because negative on the inside of the bracket. So turning point is 2, -3. 2, -3 is roughly over here. So now we need to find the x-intercepts. Let's do it. X-intercepts, y equals 0 as usual. 0 is equal to 2x minus 2 squared minus 3. Take 3 to the other side. 3 over 2 is equal to x minus 2 squared. Now we need to take square to the other side by square rooting. So square root of 3 over 2. So remember plus or minus x minus 2. And lastly, take 2 to the other side. It will be 2 plus or minus square root of 3 over 2. 3 over 2. Right? So pretty much your 2 x-intercepts are x is equal to 2 plus root 3 over 2, or 2x is equal to 2 minus root 3 over 2. That's it. Okay? So 2 plus root 3 over 2, let's say, is roughly here. Before we start sketching though, let's also find the y-intercept. So these two are my x. Let's also find the y-intercept. Y-intercept. X equals 0. Right? So you have y is equal to 2. So again, I'm working off this equation, guys, because it's easier. So you have 2, 0 minus 2 squared minus 3. So y is equal to pretty much 2 multiplied by 4, because -2 squared is 4 minus 3. Y is equal to 8 minus 3, which is equal to 5, like so. So your coordinates are 0 and 5. So 0, 5 is going to be up here. That means your other x-intercept will be here, roughly. And yeah, so label all of that, and you should know. So you have 2 plus root 3 onto here. Remember, because the plus is bigger than the minus, so pretty much this x-intercept is bigger than this x-intercept. So that means the bigger x-intercept will go on the right because the higher number is on the right, right? And then the other x-intercept is 2 minus root 3 over 2 and 0. Y-intercept is simple, 0 and 5. So again, even if you have annoying numbers, the process is still the same. See, it's my parabola, like so. Okay, so last question, which was, oh no, that was it. Okay, that was it. All right. I hope you understood everything. So, this is the basics of sketching the parabolas. Okay, don't worry, you'll get plenty of practice at this. I'll give you a whole bunch of questions. Okay, so I hope you understood everything. I'll see you next lesson. Goodbye.